In this demo, we'll create a paged list class that will handle pagination for us and will serve as a container for the current page, total pages, has previous and has next properties. Let's add a new class to the helpers folder. And let's name it paged list. We're gonna make this a paged list of T, and we just want to add a little bit of additional functionality to a list of T. So we will derive from that list of T. So let's think about what we need in this list. We will need to know the current page we're on, and we will need to know the total amount of pages. So let's add two properties for this. We'll give them a private setter so they cannot be manipulated from outside of this class. Allowing that could lead to invalid values for those properties. Two other properties that can be useful in the metadata are the page size and the total amount of items. So let's add those as well. Then we will want to know if there's a previous page or a next page. Those are properties we can calculate from the current page and total pages properties. Has previous should be true if current page is larger than 1. And has next should be true if current page is smaller than total pages. Then we'll need a constructor for this. We'll accept the list of T, containing the items, a count, which contains the total amount of items in the list, page number, and the page size. Those are the values we pass in when constructing this. From that, we can already set 3 of our properties: the total count, the page size, and the current page. Total count is the count that's passed through. Page size is the page size passed through, and current page is simply the page number. The total amount of pages can be calculated with math.ceiling. We divide the count by the page size and call math.ceiling on it. Math.ceiling returns the smallest integral value that is greater than or equal to the input. So if we have 101 records with a page size of 10, this will return 11. We cast the result to an int and assign it to the total pages property. And lastly, we call addRange, passing in the inputted items. addRange is a method on list of T, which the paged list class derives from. So this adds all the items to the underlying list. We will not directly call this constructor. Instead, we will add a static method, createAsync, that will create this paged list for us. Doing this allows us to call pagedList.createAsync, passing through an iQueryable, which is exactly what we get after applying the where clauses in our repository. All casting and calculations required can then be done in the createAsync method, rather than having to do all of that manually before constructing the paged list. So, this static method returns a paged list of T. It accepts an iQueryable of T, the page number and the page size. That is all the information we have in our repository method. To be able to call the constructor from this method, we need to calculate the total amount of items and the correct paged items. To get the count, we call count on the source. To get the actual page with items, we do the exact same calculations as we did in the repository in the previous demo. We skip page number -1 times page size and we take the page size. Then we call toListAsync on this because we need these items. That's defined in Microsoft Identity Framework Core, so let's import that namespace. Now, this does mean that 2 queries will be executed. The first time to get the amount of items, and the second time to get the actual list of items. And this is okay. The count is necessary to be able to return the metadata to the client, so that warrants that additional call into the database. Count doesn't return anything except for the actual count, So it's not like all the items will be fetched and returned from the database. And the fact that toListAsync results in query execution is also okay, because as we learned in the previous demo, paging is the last thing you want to do on an iQueryable before executing the query. And with that, we've got all we need to construct our paged list. So we call into our constructor. And that's it for the paged list class. Now let's use this. First, let's change the repository contract. So our getAuthorSasync method returns a paged list of author. I of course need to bring this into scope, so let's import the required namespace. Then let's do the same in the implementation. And let's scroll down. There's no need anymore to apply these calculations here. The createAsync method on our paged list will take care of that. So what we can do now is call into pagedList.create. And we can pass through the iQueryable, that's the collection variable, right up to the skip statement. We also pass through the page number and page size. We no longer have to call toListAsync because that is done in the createAsync method. And we also no longer need this code from the previous demo. Let's give this a try. We're back in Postman. Let's send that request from the previous demo again, in which we try to get the second page, assuming 5 items per page. And we indeed get back the same 2 authors. So far, so good. We now have a reusable paged list, and on it are all the properties we need to create the metadata from. Let's do that in the next demo.